This video is going to do a quick review of factoring trinomials that come in this form: ax squared plus bx plus c equals 0. Okay, I want to start easy with a quadratic whose a term is equal to 1. Okay. Now, this quadratic, the a term is equal to 1, but it doesn't quite look like this. And in fact, this 0 is very important. We need the quadratic to equal 0 in order to be able to solve it. So the first thing that I need to do is remove this 2x by subtracting it from both sides. So minus 2x. When I rewrite my quadratic, I want the square term to come first, the first degree term, the x to the first power, to come second, and then the constant to come third, and then 0 on the other side. I am going to rush through this a little bit. I am presuming that you do remember the basics of factoring when the a term is 1, because we've been doing that a lot in class lately. If that's not the case, you should come to office hours. So a lot of times in class we've seen this. We split our quadratic into two binomials. We put the x in the first position of both binomials, and then we're looking for constants to go in these two positions. Now we come up with the constants by factoring the c term. The c term is negative 24, and I need two factors of the c term that add to the b term. So here's the b term. So I start thinking of factors of negative 24, and the first one that I can come up with is 2, and I know 2 times 12 gives me 24. Now, if one of those had a negative sign, because we'd need one of them to be negative to get that negative 24, is there any way for those two to equal negative 2? 2 plus 12 is 14. 12 minus 2 is 10. I just can't think of a way to get to 2, so that's not going to work. The next factor of 24 I can think of is 8. Let's play around with the 3 and the 8 with addition and subtraction. 3 plus 8 is 11. 8 minus 3 is 5. 3 minus 8 would be negative 5. None of those get me to negative 2, so that's no good. The next factor of 24 I can think of is 4 and 6. Okay, let's see. 4 and 6. Is there any way to add and subtract those to negative 2? Well, yeah, 4 minus 6 gives us negative 2. So if this was negative and this was positive, we would have the negative 2 that we need. So that's what we're going to do. We're going to insert x plus 4 and x minus 6 into those blanks. And it does not matter what order that you do that in. And you'll recall in Algebra 1 you learned about something called the zero product property. And that basically says that the only way you can get 0 as an answer in multiplication is if one of your factors, or both, is 0. So we can say with confidence that either x plus 4 equals 0 or x minus 6 equals 0. And then we solve those equations separately. So we get x equals negative 4 and x equals 6. And that's my answer. I box both of those or circle them. A second degree equation has two answers. Alright, so let's move on to a more difficult kind where the a term is not 1. If you notice on the next slide here, we have an a term that is 2. So this will be more difficult. Okay. The first thing I notice is that it is not ready to go because we do not see it equal to 0. So let's fix that. 2x squared plus 9x, that part's okay. 18 should come to the other side, and then we have it equal to 0. Okay. Now, the 2 makes this a little bit more difficult because when we go to set up our binomial, we have to take into account that it can't just be x and x anymore. One of these is going to need a 2 in front of it to get the 2x squared back. The other complication here is that when we go to factor negative 18, it's not quite as easy to add the numbers together to get the b term, because the problem is that this constant is going to be doubled. So it's a lot to keep track of if you're going to use a guess and check method like we were using on the previous slide. So what I'm going to do is I'm going to show you a little maneuver that you can use to take some of the guesswork out of this. So in this procedure, what I do to avoid having to guess so much, I do the following. I set up my parentheses for my two binomials, and instead of having a 2x and an x, I put a 2x in front of both binomials. Now I know what you're thinking. You're thinking 2x times 2x, that's 4x squared. That doesn't make any sense. Well, here's what I'm going to do. I'm going to put an extra 2 down at the bottom in the denominator of a fraction to compensate for this extra 2 that I have. Yes, 2 times 2 is 4, but if I was to divide the 2 out, we agree that we would get a 2. The next thing I'm going to do is, instead of just taking the c term, I'm going to take the a term times the c term. The a term times the c term, 2 times negative 18. What does that give us? That gives us negative 36. Okay. And now I'm going to factor negative 36 the same way that I did on the previous slide, thinking of factors of this c term, or new c term, which is really a times c, that add to 9. Okay, let's see. All right, first thing I can think of that goes into 36 is 2. Let's see, 2 and 18. Is there any way to get 2 and 18 to combine with addition or subtraction into 9? Well, doesn't seem like it. Let's move on. Let's try 3 and 12. That looks promising. If I took 12 and subtracted 3, then I would have 9. So it must be that I need a minus 3 and a positive 12. Now, the beauty of this little maneuver is that since both of these have a 2x in front, it does not matter which order you put the minus 3 and the plus 12. Minus 3 plus 12. Now, we're not done yet. We have that extra 2. We have this fraction that I've created, and that 2 needs to go away. All right, so you're going to look in both factors. You're looking for an extra 2. We need this one to go away. I don't see an extra 2 here. 3 is not divisible by 2. There's no way to get rid of an extra 2. But if you notice in the second factor, both 2 and 12 have a 2 in common. So watch what I'm going to do. I'm going to copy the 2x minus 3. That's okay. But I'm going to take out the common 2 in 2 and 12. And that would leave me with x plus 6. And now, what do you notice? A 2 on top, a 2 on bottom. Those cancel. So here we go. We have 2x minus 3 and x plus 6. Now, we want to solve the quadratic. So all along, I should have really been bringing down this equals 0. And so now I have either 2x minus 3 equals 0 or x plus 6 equals 0. That would give me 2x equals 3, and if I divide by 2, I get x equals 3 halves. And x equals negative 6. 2 answers for my second degree equation. All right, let's do one more. And this one is actually nicely set up for us because it equals 0. But it's got one of those pesky a terms other than 1, so it's got a 6. So I'm going to show you that maneuver one more time. So hopefully you recall that I set up my binomials just like I would any time I was factoring a quadratic. And for this maneuver, I put a 6x in the beginning of both sets of parentheses. Now, we've agreed that's too many 6's, right? 6 times 6 is 36. So I compensate by putting an extra 6 at the bottom of a fraction in the denominator. And that 6 will go away if this is a factorable quadratic. All right. Now, the procedure is you take the a term times the c term. That's 6 times 8, which is 48. And then you factor 48. Oh, sorry about that. Let's erase that stray mark there. Okay, so that was a 48. You need two factors of 48 that add to 19. Okay. All right, let's see. First thing I can think of for 48 is 2. 2 and 24. Is there any way to get 2 and 24 to give me 19? Not going to happen. Need something else. All right, is 3? Does 3 go into 48? Let's see. 3 goes into 48, 1, and then 6 times. 3 times 16. Would that give me, or excuse me, 3 plus 16. Would that give me 19? Oh, yes, it would. So that means I can pop in plus 3 and plus 16 into my binomials. Now, I need to get rid of this 6, so I'm looking for an extra 6. And in this case, I don't see an extra 6. 6 doesn't go into 3 or 16, so how am I going to get rid of this 6? Well, let's take another look at 6x plus 3. I can't get a 6 out of there, but I can get a common 3 out of there. If I take a 3 out, I'm left with 2x plus 1. And then let's use a different color here. 6x and 16. Now I can't get a common 6 out of there, but they are both even, so I can pull out a 2. And if I pull out a 2, I'm left with 3x plus 8. And let's go back to the black. Okay. And what do you notice here? What's 3 times 2? Well, it's 6. So together, the 3 and 2 will cancel out the 6. And I've got my 2x plus 1 and my 3x plus 8 factors. We'll set those equal to 0 separately using the zero product property. And that means 2x equals negative 1 divided by 2. We've got negative 1/2 as one answer. Divide by 3, divide by 3. Or negative 8/3 as another. Two answers for a second degree equation. Okay. Keep in mind that you can plug these in to check them, and then you can also FOIL your binomials back to check that they give you back the original quadratic. Hope that helps. Please stop by office hours if you need extra assistance.